In this section, one of the presented problem-solving strategies is to use a table of values to evaluate the limit. So let's take a look at how to do that. If the limit we're evaluating says that x is approaching a, then we need to make a table with a column containing various x values. The way that I've set this up, x equals a would be right in the center of this table. Above that, these are all points to the left of A. Below that, these are all points to the right of A. So if I were to look at like a number line, for example, everything above the x equals A row would be to the left. So this would be the farthest point, maybe a little closer, a little closer, a little closer, a little closer. I'm getting very close there. And then everything on the bottom half of the table would be right side, so farthest away from A, closer, 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 etc. So we're picking these in a very organized fashion. Notice that I'm subtracting 0.0001, then I'm subtracting 0.001, so I've just dropped one of the zeros. And then I drop another 0 to move up to the next row, and then I drop another 0 to move up to the top. And I'm using those same increments added to A on the bottom half of the table. Once I have that column complete, I can then move on to the second column in this table. This is the function that came from the limit expression for the problem we're trying to solve. So for this function, I'm going to evaluate it at every value in the left column. So one at a time, I'll plug those into my function to see what the output is. Now, I bet at this moment you're thinking, oh, that's a lot of work, and you're right. But we have technology on our side, so we can calculate this rather painlessly. And we won't do this for the entire semester. This is just where we're going to start to understand what's going on with these limits. When I used to meet with my students face-to-face, we would use our calculators in class to make tables. If you do have this calculator, I'll quickly show you how to make a table in this calculator. First step, you need to hit the table button. Once you do, it'll open up a menu. In that menu, you want to pick the second option. It'll say Edit Function. You can either scroll down using the scroll button, or you can hit the number 2 and it will take you to the Edit Function menu. Once you're there, you will type in the definition for your function. This can be rather tricky because sometimes formatting function definitions looks very strange in a calculator, so be careful here. After you've typed in your function, you'll press Enter. Then you'll set up the table. So you'll go back to your table button, and this time you'll do table setup. You'll need to tell it where to start. This is where the A value will go. So if our limit is approaching x equals 2, then I would start by putting 2 in this position. Then I'd scroll down to the next step, which is asking us for our step size. Now this, most likely we won't use, because this automatically generates the x values and we don't have a neat pattern for what we want. So instead, you're going to move the cursor down again. It'll highlight auto, but we don't want auto. We want to manually select the x values. So if you push over again, it'll allow you to type in one by one the x values that you want, and you can edit that table. That's one way of doing it. Another way to generate the values that go into this table of values is to use GeoGebra. So first thing I'll do is type in the definition of my function. So I'll start with f of x equals x squared. So just for an example problem, we're going to start there. Next, I need to know where the limit is being calculated. So for example, I'm going to pick to have the limit calculated at a equals 2. So then I'm going to use that a equals 2 to create a point. So I start with parentheses because points require parentheses for that ordered pair. Then I'm going to type in 2, that's the a value, plus, and then I'm going to use any letter I want as a placeholder. I'm going to use the letter B. So in the parentheses, I have 2 plus B, comma. Those are my x values. 2 plus B are my x values. Next, I'm going to create the output values using f of 2 plus B, that same x value that we had in the point. After I hit enter, GeoGebra automatically places that point on the graph, and then it picks B to be some slider. So this is pretty cool because if I click on this black dot, I can change the value of B so that it moves all along my function. That point stuck to the function. And if I push the play button, it'll move all on its own. So it's pretty cool. It moved off the graph there. Now, I can change the details of that slider by typing in different values at the top. So if I wanted to do 2 plus 001, I would type that in, hit enter, and now I see the x value is 2.001, and then the output value is 4.004001. So we can do this piece by piece, filling in the table so that we have all the values that we need to make our decisions. Now that we know how to make a table of values without really wasting a lot of time, let's talk about using these tables to answer questions. So you're going to need to practice using GeoGebra or your calculator or whatever you're going to use to generate these tables. Practice that on your own time, but now I'm going to move forward and show you how to use the tables. So let's say that we want to calculate the limit that's on the screen. So we have the limit as x approaches 2. And we're looking at the function x squared minus 4 divided by x minus 2. So from this, I can tell that a is equal to 2, and that f of x is equal to x squared minus 4 divided by x minus 2. So we're pulling that information from the statement that we see on the screen, that limit statement. From that, we generate our table. So notice that in the column of x values, I've replaced all of the a's with 2. And then in the column of the f of x values, I'm just showing that I'm going to plug those numbers into the function. Once we calculate all of these, we can finish the table, and we'll see the different values that I have on the screen. So either using your calculator or GeoGebra, you'll come up with these numbers. Notice that at x equals 2, our function output is undefined. And that's exactly why we're using our limits here to make this table. But if we look at what happens as the x values gets closer to 2, our function value is getting closer and closer to 4. Same with the bottom half of the table. As these x values get closer to 2, our function value is getting closer and closer to 4, just like we saw in the picture. So if you remember, this graph was a straight line, but it had an open circle at x equals 2, and we said our function was approaching the value 4 no matter which side we were coming from. So we can use this table to see the trend that's happening. Our function is getting closer and closer to the value 4. Let's look at another limit statement. So in this limit statement, x is approaching 0, so we know that a is equal to 0, and the limit has the function f of x is equal to sine x over x. So again, using our calculator or GeoGebra or whatever we want to use to generate these values, I'm going to create my table, one column of all the x values, replacing a with the value 0, and then one column of my function evaluated at each of the x values in the left column. Once we calculate all of those, we can start to see the trend that's happening. So remember, as we're zooming in towards that middle part of the table, the x values are getting closer and closer to 0. And if we look at the function output, we really have to keep quite a few digits at the end of our decimals because they all look the same. So when we're the farthest away from f, We're at 99.83342 on the right, and the same thing on the left. And as we move in, we're getting closer and closer to the value, which looks like it's approaching 1. So 0.9999 with a lot of nines. That's getting us closer and closer to 1. So for this limit, I would say that as x approaches 0, the function sine x over x is equal to 1. Let's look at another function. This limit has x approaching 4, so a will be replaced with 4, and then the function definition is the rational function, root x minus 2 on top, x minus 4 on bottom. We come over to create our table of values. The x column has 4 minus all of our small increments, as well as 4 plus all of our small increments. And then we're going to evaluate our function at each of those x values using our table, GeoGebra, whatever we like. We complete the table of values, and we look to see if we can notice a trend in that function value column. So as we're getting closer and closer to the middle of our table, can we see that our function output is approaching the same value? 0.24998438, that's really close to 0.25. And on the other side, 0.25.001563, that's also really close to 0.25. So we're seeing the trend. We can then conclude that the limit where x is approaching 4 for the function root x minus 2 divided by x minus 4, that's got to be equal to 0.25. Now that we know how to use this table of values to see the trend that's happening with the function outputs, let's take a break and look at some pictures. Math with pictures is always much more fun. Well, maybe not always. But if we were looking at the function on the left side of the screen, we're asked to find the limit where x is approaching -1 for the function that's graphed. So if we look at x equals -1, that's right here, and if we follow that up onto our function, we can see something that's a little bit confusing here. The function is passing through an undefined point, but the function's actually defined to be up here. So if somebody had said, what happens to g when you plug -1 into it, you have to use the solid point. The function output here should be 4, because that's where the solid point is, even though it's not on the nice smooth curve. But if we want to talk about the limit, we have to say, cover up everything that's happening around -1. So pretend like you can't see that part of your function. If you can't see what's happening at -1, what would you guess your function is approaching? So from the left of -1, I'm following my function, and I'm saying, where am I going? Oh, it looks like I'm headed right to 3. So this horizontal line is at 3. And even from the right side, if I'm following along my function, it looks like I'm going to 3. But if we had the full picture, we'd say, oh no, we're not going to 3. The function jumps up here. So this is tricky because the limit is heading to 3, even though the function is defined to be at 4. So even though there's that removed point, the limit is still leading us towards 3. The function value is not going to change that limit for us. Let's look at a simpler one just to give ourselves a break. On the right side of the screen, we have h of x graphed, and we're asked about the limit where x is approaching 2. So we come to our picture, we find x is equal to 2, and we follow that to our function. We do see an open circle here, so we know the function's not defined right there, but we're not asking for what the value h of 2 is. We can see it's undefined. We're asking what the limit is, meaning if we walk along the function heading towards that x equals 2, what is our function heading towards? And from the left, it looks like it's coming close to the function output of -1. Let's see if the same thing's happening from the right. As we're getting closer, we're also at that -1 output value. So as x is approaching 2, our function is approaching -1.